Okay, there's a couple extra problems in 1.8 I wanted to cover. So this is 1.8. This is a continued. So what we got here is we're going to look at like two examples real quick. So these are what happens if, let's say we got something like this. And so we have a absolute value inequality, but it's not compared to 0, or you don't have the absolute value part by itself. So what we're going to do with these types is we're going to say first what we need to do is isolate the absolute value. So in order to do that, we're going to add 1 to both sides here. So we get 3 absolute value of 4x minus 1 is less than 12. Second, we're going to go through and divide both sides by 3. So the 3's will cancel here. So now we get our absolute value by itself. And we got that it's less than 4. So this is a less than inequality where the absolute value is the smaller amount. So its absolute value is less than 4. So 4 is the larger amount. So this turns into the triple inequality type that we saw earlier. So we get 4 and negative 4, and the 4x minus 1, the part that was inside the old absolute value, that is stuck in between them. We're going to add 1 to all 3 places. This will make a negative 3. Oops. Negative 3 is less than a 4x is less than a 5. We divide them all by 4. So these cancel. So basically we get negative 3/4 is less than x is less than positive 5/4. And in interval notation, this would be negative 3/4 up to 5/4. There's no or equals under these, so we're going to use open brackets on both of these and say that is what we got. So we'll look at one other type of these when the inequality goes the other direction with sort of the same style of solution. So let's say we had, for this example, let's say we had 2 times absolute value of negative 3x plus 2, and we got a minus 1, and this time it's greater than or equal to 7. We want to solve. So step 1, get the absolute value by itself. So we'll add the 1 across first. So we'll get 2 absolute value of negative 3x plus 2 is greater than or equal to 8. We'll divide both sides by 2 because our goal is to get the absolute value part completely by itself. That'll leave me absolute value of negative 3x plus 2 is greater than or equal to 4. So this time, the absolute value is the larger part. The absolute value is greater than or equal to 4, so 4 will be on the smaller part of the inequality. So this one splits up into 2 inequalities. We're going to write down for the first part, we say the negative 3x plus 2 has to be greater than or equal to 4. So you just kind of write the equation down with the absolute value dropped. And for the second part, we get negative 3x plus 2 is less than or equal to negative 4. Now we're going to solve these individually for x, and then we'll write it in interval notation. So I'll subtract 2 from both sides. I'll get negative 3x is greater than or equal to 2. I'll divide through by negative 3's. This will give me x is greater than or equal to negative 2/3. Oops, just kidding. All right, so I divided by a negative. So my inequality flips. So it was a greater than, it's actually x is less than or equal to negative 2/3. So you need to be careful about that. If you multiply or divide by a negative number, the inequality direction flips. So over here, I subtract 2. Subtracting does not change the inequality direction. It stays going the same direction. Then I divide by negative 3. Dividing by a negative, this does flip the inequality because I divided by a negative. So I get the negative 3's cancel here. I get x is greater than or equal to negative over negative is positive. 6 divided by 3 is 2. So I have x is either less than negative 2/3, which would be negative infinity up to negative 2/3, or is equal to negative 2/3, so it's okay to equal negative 2/3. Out here I have x is greater than or equal to 2, so that's going to be 2 on up. And we join those with the union, and that'll be our answer in interval notation. So we'll stop there. That was the last couple examples I wanted to do from that section. Same thing would happen, I guess, if we had an equals in between them, we'll just say. So like if you had, say, 2 absolute value of x minus 3 plus 6 equal 20, you'd have to isolate absolute value first, then solve. And so it would have kind of a similar thing there, but instead of an inequality, you would have equals. It works the same way. So we'll stop there on that and move on to section 2.1 next.